Hey everybody. Okay, so here is a continuation of what we were talking about on the last video, which is my commute. So here is an elevation chart of my commute. I start over here, and if you remember, you probably don't, that's okay. I start at my house at 3,400 feet above sea level. And I end up at my office, which is about 4,000 feet above sea level. About 4,000 feet above sea level. So I end up with a rise of about 600 feet in this way. 700 feet. So it must be 4,100 feet, I'm sorry. 4,100 feet. So I go 34 to 4,100. Regardless, the rise is essentially 700 feet. So we know that. 700 feet. We'll put that up here in the corner because we're going to need that in a second. Now, what you got to remember is that I lose and then regain distance. So when I start at 3,400 and come up and then drop and then regain, if I only look at the start and the end, I don't actually take all those little drops into consideration. I simply go, you started at 3,400, you ended at 4,100. I mean, that's the extent of it right there. So 3,400 to 4,100, that's 700 feet vertical gain. So what it's essentially doing is, if I ignore the entire middle, is I'm pretending that I'm doing that. Pretend that goes to the top. I'm pretending that the entire commute is a uniform, linear, smooth line. We're going to talk about this a lot in this class, especially when we talk about things like average speeds and things like that. So that is what we're going to assume. We're going to talk about my average grade. My average grade over a distance. And average grade, that's grade by the way. Hopefully you've gotten used to my horrible handwriting by now. My average grade for an entire distance is just, all it is it's rise over run. It's what all it is. It's rise over run. It's total rise over total run. It's total rise over total run. So all we've got to do, we're going to ignore all of this shucking and jiving up and down and just say, you know what? You started at 3,400, you got to 4,100, that means you went 700 feet. That's it. You went 700 feet. No problem. Now, how about the run? Now, the run is a little bit tricky for two reasons. The simpler of the two reasons that it's tricky we're going to deal with right now. The slightly more nefarious of the two we're going to deal with in the next video. So I start at 0 miles and I go to 6.1 miles. Which means I've gone 6.1 miles. But I can't put 6.1 in for the total run. Because 6.1 is measured in miles, and I need my number measured in feet. So we have one of two things we can do. We can change 700 feet to miles, which I don't recommend doing. Most of my students don't like doing that either because you end up with this tiny little decimal. People just don't like decimals as much as they like whole numbers. So I think it's probably easier to change 6.1 miles into feet. And now we're going to do some more dimensional analysis because I know that you all love that. At least that's what you said in class, right? So I'll do it down here. So if I have 6.1 miles over 1, just like somebody told me in class, and I forget who that was, I'm going to multiply that by a conversion factor that's going to change miles to feet. And we know, and if you don't know, you're going to know now, that 1 mile has 5,280 feet in it. And then our miles are going to divide off, and we're left with just 6.1 times 5,280 feet. I will get us that number. 6.1 times 5,280. I end up with 32,208 feet. I'm going to call it 32,200 feet. I think that 8 feet is probably a little bit too precise for our own work. It's because the 6.1 is rounded off anyway. It could be 6.09, it could be 6.12. We'll deal with Strava later as we go. So I get 32,200 feet. So that's 700 feet divided by, I'm going to keep using the orange one if that's okay, because I think the orange is popping better. 32,200 feet. Notice now, we're both feet, top and bottom. They divide off, and we're left with 700 over 32,200. That's 7 over 32.2. Let's get some precision. I can't do that one in my head. 7 over 322, which clocks in at just about 2%. Clocks in at just about 2%. So you think to yourself, wait a minute, how can it be 2%? You just showed us Archie Briggs, which is 17, whatever it was, 17.6, 16.7, I forget what number it is, steep. You just showed us parts of College Way that are equally steep in different places. You ride up both of those. I didn't even show you the College Loop Road that I go up, and I go up the trail next to it, which is even steeper. How can you have an average grade of 2%? Pretty easy, actually. This one here is negative. That one there is negative. Yeah, there are certain parts that are super steep, but there are also certain parts that are super flat. When you average them all together and spread them out, which is what averaging is all about, more on that later, when you spread out all those grades, you take the steep ones and build up the negative ones, and you take the somewhat steep ones and build up the flatter ones, it ends up averaging to a 2% grade. Now, the more astute of you are going to notice that when you look at this graph, that line looks a heck of a lot more than 2%. And that is 100% correct. It is a lot more than 2% because this is measured in miles and this is measured in feet. As a matter of fact, where is my, here it is. This, I showed this to you in class yesterday, but it was very quick. This is what my commute actually looks like if you scale it properly. See that blue line? That blue line is my actual commute. And the reason it looks like that is because I've actually scaled it properly. Here are the feet in elevation, and here are the feet in the distance. It does tilt up. My head's in the way now. It does tilt up from 0 through 6.1 miles. It's just an incredibly small tilting up, 2% to be approximate. So that, my friends, is how you can pull a grade off of an elevation map. Average grade of an entire trip, your total rise over your total run. It's kind of like average speed, total distance over total time, which we'll come back to in this class as well. So you ignore all the individual stuff in the middle and just focus on the beginning and the end. The total rise from beginning to end, 700 feet. The total run is 32,200 feet. Except now we have to deal with concern number 2. And concern number 2 is that the actual run is not 32,200 feet. We'll deal with that in the next video.